Okay, this video is going to be about how to do limits. We'll need to cover this in several videos, but let's begin. The first kind of limit that you should understand is what I like to call easy limits. Okay? And this kind of limit is basically the kind of limit where you can just plug the number in. Okay? What about if we have a question like this? The limit is x goes to 3 of 2x plus 5. Well, in this kind of question, you can just put the number 3 right in there, like substitute it in and work it out. And there's no problems with things being defined, right? 2 times 3 plus 5, that's perfectly defined. So you're allowed to just plug that in and get an answer right away. 2 times 3 is 6 plus 5 is 11. So that's why I call it an easy limit, because there's nothing tricky going on there. What about something like this? The limit is x goes to 3 of x plus 3. Whenever you do a limit, you should always put the number in to the function here and see what you get. If you get a 0 on the bottom or a 0 on the top or something like that, then you have to maybe think a little bit harder. But for easy limits here, all you have to do is just put the number in. Notice when I put 3 in the bottom here, I get 6, right? And that's perfectly fine. So I just put the number in, and I get my answer right away. Now, these limits don't come up too much, do they? Because they're so easy. But they do come up sometimes. What about something like this? The limit is x goes to 0 sine x. Well, I'm allowed to put 0 into sine, that's no problem. So I get the sine of 0, which I hope you know is 0. You can use your calculator for that if you want. Just as a side note, whenever you use trig functions in calculus, make sure you have your calculator in radians, okay? Because all of calculus uses radians. So those are easy limits. What about the next kind of limit, which is what I like to call the form 0 over 0. So let's say we have a limit and we put our number in and we get 0 over 0. That's the next category of limits that I want to talk about. They're the form 0 over 0. Notice I put the 0 over 0 in quotation marks. That's just because, you're never allowed to have 0 in the bottom in math, okay? It's okay to have 0 in the top, but you're never allowed to have 0 in the bottom. So, just as a side review here, if I have something like 0 over 5, this is perfectly fine, okay? This is no problem. This is 0. But if I have something like 5 over 0, this thing here, this is undefined. So, if you ever find yourself writing an expression like 0 over 0 on your paper or 5 over 0, if you ever give that as an answer, you know for sure you've done something wrong. So I just wanted to review to you that 0 over 5 or 0 over a non-zero number is just fine. The answer is 0. But anything over 0 is always going to be undefined in math, okay? So let's remember that. Now, let me give you an example of this kind here. Say the limit is x goes to 4 of x squared minus 16 over x minus 4. So we put the number 4 in here, right? 4 squared is 16. 16 minus 16 is 0. So the top is 0, and the bottom is 4 minus 4, and that's 0 too. Now sometimes I see students writing some stuff like this. Okay, this is total nonsense. Don't ever do that. You should, in your mind, you should say to yourself, this is 0 over 0, but just don't write it on the paper, okay? Just think to yourself, when I put the number in, I get 0 over 0. So that means I have to use, often when it's 0 over 0, do you know what your strategy should be? You should use some algebra to simplify the expression. So use algebra maybe to factor it, okay? That's one possible strategy. So the bottom, we can't factor the bottom because it's a 1 degree polynomial, but we can actually factor the top, right? It's a difference of squares, right? It's x minus 4 times x plus 4. And here's where you need to have your algebra up to speed to recognize that you can factor that. And you see here, these x minus 4's, they cancel now, don't they? So now, what are we left with? The limit is x goes to 4 of x plus 4. And the thing is, this is now an easy kind. This is the kind of the one we just talked about, because I can just put the number in, right? I get 4 plus 4, and so the answer is 8. All right. Let's try another one. Just going to erase this. That's a little bit. So why don't we try just another one here? Another kind of use algebra to factor, or maybe you want to use algebra to do something called rationalizing the denominator or the numerator. Okay, maybe you've seen the rationalizing technique used on the denominator, but you can use it in calculus for the numerator as well. So I shouldn't have erased that, sorry. This is the type 0 over 0. So we're still thinking about the type 0 over 0, okay? So what about if we have something like this? A limit is x goes to 9 of root x minus 3 over x minus 9, okay? So as always, it's a good practice, just in your head, put in 9 into the top and bottom and see what you get. When I put 9 into the top, I get root 9 minus 3, which is 3 minus 3. So the top is 0. When I put 9 in the bottom, I get 9 minus 9, which is 0. So I have 0 over 0 here, don't I? So there's a technique called rationalizing, which is going to allow you to solve this kind of a limit. What do we do? Well, I'm just going to recopy this. I'm going to put big brackets around it. And then over here, I'm going to multiply this by 1, okay? Certainly that doesn't change anything, right? When I multiply by 1, it doesn't change. But I'm going to write 1 in a strange way, though, okay? You should know that anything divided by itself is 1. Like a over a is always equal to 1, no matter what a is. Well, as long as a is not 0. So what I'm going to do is I'm going to go root x plus 3 on top and bottom. Has to be the same thing on the top and bottom, because you know what? This expression here, this is really just equal to 1. It looks pretty strange, but it really is just equal to 1. And let's multiply that out now and see what we get. When I multiply out the top, there's really 4 terms here, right? But root x times root x is x. You should know that. Root x times 3 is 3 root x, but then in the middle I have minus 3 root x, so those cancel. And minus 3 times positive 3 is minus 9. Oh, and the bottom here, don't multiply out the bottom, keep it factored, okay? The reason we want to do that is because now, notice we have x minus 9 on top and bottom, and we can just cancel those guys. So what do we get? We get the limit as x goes to 9 of 1 over root x plus 3. And now we're back to those easy kind of limits where we can just put the number right in, right? So we get 1 over root 9 plus 3. Well, root 9 is 3, and 3 plus 3 is 6. So our answer is 1 over 6. So whenever you come to the form 0 over 0, you should always think that maybe I should use algebra to factor it, or maybe I should use some rationalizing technique like we've done here. If this is a minus here, okay, on the root, you put pluses here. If it happened to be plus there, you would have wrote minuses there. Thank you. This is the end of this video.